So here we're looking at the graph of cosecant, and remember cosecant is the reciprocal of sine, right? It's equal to 1 over sine of x. And what this means is that whenever sine of x is 0, like at 0 or pi or 2 pi, then we'd be dividing by 0. So you'll notice on the graph, all of those places we get a vertical asymptote, okay, where it's undefined there. 0 would be one of those places. Okay, so that means those values can't be in our domain. So the way that we write out the domain for sine of x is all real numbers except for pi k, where k is any integer. So we're saying any multiple of pi, 0 pi, 1 pi, 2 pi. Here it'd be negative 1 pi, negative 2 pi. You get an asymptote. It's undefined. Okay, now you'll notice here that the smallest, so it goes up toward infinity. So if we think about the range, these are going down forever. So it's going to be negative infinity up to negative 1. Okay, but then there are no graphs in here between negative 1 and 1. But then we pick up from 1 to infinity. So the range really are all numbers except for the values between negative 1 to 1. Okay, it's not a continuous function because we see we have those asymptotes. Okay, you couldn't draw the whole thing without picking up your pencil. Okay, it's an odd function. And remember that means from the identities that cosecant of negative x would be equal to negative cosecant of x. Okay, and if you think of kind of one period of the graph would be, well, we can actually, oops, sorry about that. Look at this one from 0 to 2 pi, we get kind of one of the copies that's going up and one that's going down. Together that makes one period of the graph. So the period is 2 pi. So that's our graph of cosecant of x.